All right, well, let's get started. So my name is Brendan. I am a senior engineering manager at GumGum. We're an ad tech company. My role at GumGum is overseeing a couple of different data teams in the media side of our business. So data engineering team, where we're processing tons of data using Databricks and a lot of other technologies. The business intelligence team, where we take all that data that we processed and make it useful for the business. And most recently, the data science team, which is actually a new investment in our media division. And so that's what we're going to be talking about today. How we position this team for success, how we give this team the tools that they need to produce value for the company, and how we actually execute and deliver on that. Awesome. So before we get too into the weeds here, a little bit about what GumGum is. We are an ad tech company. Our goal is to connect advertisers, people with a product, a brand, a message that they want to share with consumers. And we want to shape a meaningful connection between that advertiser and a potential audience. So someone looking at a video, a page, gaming, anything like that. We want to make those connections. And our unique angle on it is we want to be able to do that without leveraging personal data. We want to offer an avenue where you can focus on the mindset that the user is in, the property of the page that they're looking at, and some really cool CV and NLP technologies that we enable to allow us to, advertisers to do that. So what this actually looks like in a very simple example of this, if you're a user and you're loading ESPN.com or Yahoo, and there's an opportunity to serve an ad, so within a 200 millisecond window, that web page will reach out to GumGum, and we're going to make a ton of different decisions. We're going to have a ton of different conversations with a bunch of partners in the ad tech ecosystem, including Trade Desk, who's speaking later. And ultimately, we're going to try to do our best to pair that advertisement opportunity with an ad creative that perfectly fits in that space and time. And so our unique angle on this is to use our Mindset Matrix product. So we actually this came up a little bit in the earlier panel, but essentially our idea of mindset is understanding, what the user, obviously we want to be able to, it's valuable to know who the user is, but we think it's even more valuable to know exactly what the user is feeling in that moment. If I'm doom scrolling, about climate change and things like that, maybe I don't want to see your product right next to me at that time. If I'm, on a nostalgia trip for my favorite Eagles Super Bowl moments, sorry Phil, who's a Cowboys fan, go Birds. It's the perfect time to sell me a jersey. So we really want to be able to capture that moment, that mindset, and we have a unique set of proprietary technologies, including contextual, engaging creative insights, and then one of our newest products, which is attention, which is a really novel way to look at how people are looking at ads. And so this is kind of GumGum's mission. We're actually not going to go too deep into the mindset stuff today. We're actually going to be talking more about the ad exchange and some of the operational side behind that. So, as I said, we're making all these decisions in this 200 millisecond window. We're processing billions of decisions every hour, every minute, every day. And we want to operationalize this by putting this in some sort of data receptacle. Maybe it's a data lake, a data warehouse, data lakehouse. Doesn't really matter. The whole point is we want to get this data in front of users to serve business functions, whether it's an external report that says, this is how your publisher traffic's looking today. Maybe it's an internal report. We just signed $1 million campaign and I want to make sure it's pacing correctly. Maybe it's we just integrated with a new partner and we want to know up to the second if something's going wrong in that system. We want to have that observability. Or the golden goose for any good data platform should be the ability to produce brand-defining insights like this one, which is a very early version of what we call our Mindset Index, which helps you combine contextual and attention to really further and move your brand ahead. Now, this is a whole different presentation going into this. One of the things I want to highlight, though, is a lot of the value from these types of operationalizations is brought by users. So GumGum has a wide array of data sleuths, data experts, data owners that can take this data and provide action. The problem with this, though, is a lot of our operationalization of data today is gated and bottlenecked by the amount of users that are there to bring value out of it. And we have way more data than we have people, so we want to start carving out some pathways where our data can drive value directly. And so that's kind of the scene and the setting for where we thought a data science team, a team that is a little familiar with machine learning technologies, data analysis, generative AI, can come in and start to drive that value. So a little under a year ago, we really committed to this and formed a media data science team where we aim to do exactly that. And part of this in our data science team, our angle and our approach for this is to start implementing decision services. So a decision service, in a simple manner, is something that can answer a question. How much inventory can I allocate towards this campaign? What's the likelihood of a click on this inventory impression? Will including this parameter increase or decrease my revenue? If we can have decision services create these reliably and not have to involve people, we can integrate them directly into our applications, our business workflows, and our brand as a whole. And when we power these decision services with data, pretty commonly you'll end up with a machine learning decision services. And that's mostly what we're going to be covering today. The two kind of areas we're going to be talking about, two specific projects, and really the two focuses of the data science team that we found value in applying decision services is in the application of improving operational tasks. So teams that are doing, teams have set processes for how to execute business functions. We map out what they're doing, and then we introduce decision services that can improve efficiency, improve the decision accuracy, reduce the institutional knowledge, and get people back to doing people things, not sorting through papers, not driving insights, et cetera, et cetera. The other side of things, we're looking at automating our ad decisioning. So on the operational side, people are very involved. In a 200 millisecond ad exchange decisioning process, we don't have time to ask a person. And so there's really no other alternative but to implement these decision services to make decisions in our ad exchange process. Cool. So first off, we'll walk through kind of our story on improving the avails experience. Who here has heard of an inventory avails? Good. It's a decent amount. It's an ad tech group, I guess. But essentially, an ad avail is just a request wanting the knowledge of how many ads we can serve on a particular cohort of impressions. So if someone wants to advertise in the West Coast about luxury vehicles, we should be able to say approximately how many GumGum can commit to, so we can work with our advertisers and sell them that amount. And this process can look a lot of different ways at different companies, and at GumGum it also has looked a lot differently at different times, but more or less the way it works at GumGum before this project is how many ads can we serve. We go and update the targeting and restrictions. The user will then do some data checks on our avails forecasting tool. They'll check our historical forecasting tool. They'll consult with team members, and then eventually they'll get that estimate. And these largely, our users were dissatisfied with results. We had about 85% of users had dissatisfied scores in a survey. And it was largely due to the repetition and confusion in these three areas. These three tasks kind of signify a lack of trust in the tools and technologies that we had available. And so we wanted to improve our avail system by introducing decision services. And so we basically just went to our users, we saw what they were doing. We saw basically they had a sense of what inventory was available, and they were making some historical adjustment, largely based on win rates that they thought were intuitively true. And then they adjusted that. And so we modeled this as a decision service. We just added a win rate prediction system and walked down that initial available inventory request down to a signal that matched the user expectations. And how did we accomplish this? Pretty simply, we just started a Databricks notebook. We had a data engineer at the time, who's now a data scientist, go in and build a very quick model that could predict win rate prediction. It wasn't super accurate by F1 scores or anything traditional, but it solved the business problem really quickly. We took this, we put it in front of users, and that 85% of users that were dissatisfied results, we quickly turned that into 87% of UAT tests matching expectations. And note here, we're not really showing those F1 scores or that we're accurately predicting everything perfectly. This was actually a case where we wanted a tactical win and a tactical response applying a decision service that's driven by data. And overall, this took 4 weeks to develop in Databricks. And so this was something that we were looking at 2 year factors, breaking apart our avails process and putting it back together again. And we were actually just able to apply this quick Band-Aid, this quick patch that gave users a little bit more confidence in their avails numbers. And overall, this gave us a lot of confidence so that we can quickly and tactically apply decision services, just modeling what the business users are doing, put it into the business workflows, not creating new tools or services, but just embedding it directly into what users are used to working with, and shortening the amount of time they spend, increasing their focus, giving them time to do people things. So this was a really big win. On the other side of things, we also looked at a more strategic project, a project that we knew would be a little bit of a bigger task, and something that we wanted to put a little bit more architecture behind, and this is optimizing ad KPIs. So an ad serving KPI is whenever an ad gets served, you have all these markers of how that ad performed after it was served. So some of the examples are, like the classical example I would guess is CTR, whether a user clicked into that. And over enough impressions served, you can generate a click-through rate. Users click on this ad 1%, 2%, 3% of the time. In the last couple of years, though, there's been an explosion, or I guess last 10 to 15 years, there's really been an explosion of ad serving KPIs where you can get really cool insights into how your brand is performing after serving ads, or how are users interacting with the ads, how are users interacting after seeing your ad, and then how are users how their viewing experience is shaping on the page. And these are critically important because when we sell an ad, this is how we confirm that this is actually worth the money you're spending on the ad. Now, what we believe, and our pitch is if we can understand what these KPIs are going to be very early in the ad serving process, so as soon as we get a request from Yahoo that, hey, there's this ad on this page, if we can predict that this is an ad opportunity that can score really highly if we pair it with a certain creative, we can then route that ad more effectively to that campaign and serve the best campaign possible. This not only helps the web page because users have a better ad experience on that page when the KPIs are performing better, when the engagement is higher, but it also helps the user. They get served a more relevant ad, and it helps all our partners as well because the metrics that they're monitoring are hitting their targets. And we can do this at scale too. So any KPI we optimize for, we can kind of rinse and repeat. So whether it's viewability, CTR, attention, which is an internal metric we look at, or really any KPI. If we have the data, we can train the model, we can deploy the model, and reap those returns. Now, the challenge for this is, as I mentioned, this wasn't necessarily a 4-week project. It's because anyone who works in ad tech is dealing with ridiculous scale and complexity. We have over 10 trillion historical records that we have to choose from when training. We have 80 billion daily ad exchange events. 200 millisecond latency is our total latency cost. Generally, that could be just an ML inference latency cost, so we have to keep our latency in that 5 milliseconds max time. Our complexity is super high. We're making over 200 decisions, like major decisions, in the path of every impression. And there's a lot of considerations for dependencies and users that can be impacted by these models. And so we made some pretty big platform investments. We're not going to go into hyper detail here. Each of these could probably be its own 30-minute presentation or something like that. But essentially, the first thing we looked at is how can we orchestrate these models in the back end? And so we developed a pretty extensive framework that allows us to treat models like code. So centered in Databricks, we use the model registry framework. We use the notebook framework. Pretty much the whole left half of our MLOps orchestration happens in Databricks. It gives us the opportunity to center our development efforts and readily promote and integrate models as they reach maturity into our ad exchange. The next thing we had to solve was no latency inference. We used this really cool technology called MLeap, which helps take our models, not to get too technical, but we serialize these models into Java compatible code. And then we actually just integrate that code directly with our ad exchange. So instead of having to make a service call that could cost maybe a fraction of a millisecond or maybe a full millisecond, we can have these all of our models that are trained integrated as quickly as possible, leading to sub 1 millisecond latencies. And then finally, probably one of the most important platform investments we had to make was probably more of a cultural investment, is our experimentation framework. And so in the last year, as we've started introducing these decision services, we've been asked by executives, by ourselves, how do we know that things are working? You need observability, you need A/B testing, you need to have the ability to statistically back up what you're releasing. You can't just turn something on, hope the revenue goes up, and then have a good day from there. We really need to be able to experiment and do things quickly. So we have a pretty extensive experimentation manager application that we built that supports dynamic A/B testing. Cool. Some of the stuff isn't shown, but yeah, basically the results here that we got from this is actually, I think this was a couple weeks ago, we had our GA, internal GA, where we've released the ability to optimize on viewability. Some of the initial results are looking really good. We've seen the ability to increase viewability as much as 20% in campaigns. So to get that previously, like an ad operations specialist or a campaign manager might have to, target really high cost inventory, and we might actually lose money, targeting that high viewability traffic. Now we can do this flexibly and gradually throughout our ad serving process. We've also been able to deal with 1 million daily inferences. We've been able to deploy 94 different models, and we experience 0.5 millisecond latency in our P95 latencies for inference, which is like ridiculously low for a machine learning model. Cool. And so most of this is powered by our Databricks infrastructure. Our developers start their model development in Databricks, and they end by deploying a model from Databricks into our model artifactory. And so that's been really great. Leaving both of these projects, we kind of realized a larger investment was needed in our platform and in our approaches. I think, as was talked about in the panel a little bit, the quick wins and the low-hanging fruit are there, but really what you need is a scalable approach towards machine learning, to data-driven AI, to all these techniques. And so we've kind of developed what I don't want to say platform, because it's really not that technical. It's more of a management framework. So it's how we're thinking about ML, and we call it our ML slingshot trademark. Essentially, what this is, anyone who's seen sci-fi movies, like any sci-fi movie centered in space probably uses this thing where you slingshot around the black hole or the planet or anything with a lot of gravity, and you use it to return to home as quickly as possible. And so we do the same thing here, but with a problem statement. We really want our data scientists and engineers, given a problem statement, how can you quickly solve that problem statement as quickly as possible? And those planets, black holes, all those sorts of stuff, that's the platform that we build. So we've made some pretty extensive investments in supporting data engineering for data science, building out extensive tools in experiment tracking and data science technologies, and model management. Actually, sorry, I said we've made investments. We actually haven't had to make many investments, because a lot of these features are just natively available in Databricks. Our data engineering stack here is just notebooks, repos, feature stores, things that probably anyone with a Databricks account has tried out. Our data science space, we're using MLflow experiments, which are natively built in, not just to the back end, but there's some really cool UIs and an ability to query this information to see how our developers and data scientists are progressing as they're building these data science models. And in the MLOps space, like, this is our source of truth, our model registry. It's how do we manage the models that we're trying to send out in production? How do we promote them? How do we treat machine learning like code? It's a big disconnect in a lot of cases where data science team operates one way, the rest of the engineering org is doing something completely different. So we want to try to have similar standards and processes. And overall, to test this, we actually hosted 4 different workshops, and I think three different continents. Yeah, 3 or 4. I think we might have had South America covered. But an internal workshop series where over 50 people, non-data scientists, went through the building a CTR prediction model in Databricks, doing the data engineering, building the feature store, running their experiment, adding hyperparameters, evaluating if their model's better or worse than it was before, and ultimately just deploying a model that they can call from anywhere, whether it's an external application or just another Databricks notebook. This was a huge success. It was also really cool because we could track everyone's progress. We hit over 171 slingshot milestones as we saw people orbiting this platform that we've built and returning to that problem solution. So moving forward, it's going to be more of the same. It's actually a really exciting point, to be like, we delivered value and we can just continue delivering value. Some of the pivots we're making in 2024 are obviously incorporating Gen AI and RAG architectures. There's actually like 3 or 4 active projects in this space, specifically on the operational side, where we're doing the same thing we did with InstaVails, or the Avails problem. Taking a business problem, seeing what they're doing, and just automating that and incorporating in the same place that business users are looking. We're also expanding our whole data science stack to data mesh developers. All they need is a Databricks login, so it's pretty easy. But we have a pretty extensive data mesh program in our data engineering side. We want to extend that to data science and give these developers those tools as well. And then on our ad decisioning side, we put in a lot of the hard work, so now we're kind of going to start reaping the reward, taking that model that can predict viewability and retraining it, retuning it, building another version that can predict CTR, attention, other attribution metrics, and get that out in front of users as well. Just some high-level learnings, some lessons that we learned throughout this process. Embracing the user perspective, I think I mentioned this a couple of times, the biggest KPI we look at is user success. Are these things that we're delivering matching the expectations of the user? Observability is key for us. We need to see every step of the process, whether it's a dashboard that helps us know if our model is improving things during the A/B testing, or if it's observability into the number of releases that happened in the last month to see if teams are getting stuck on things. Two more. Delivering decisions, not models. We want to make sure the things that we're delivering are actionable and can be directly integrated. We don't want people to have one more data point to look at. We want to skip that step and go directly to the value driving. And then finally, a scalable data platform. It's 2024. If you're in the petabyte, terabyte range, like big data should not be a blocker for driving value in your business. And that's why we choose to invest in platforms that give us the maximum amount of time on feature and not time, troubleshooting cluster management, dealing with big data, traditional big data issues that I'm sure a lot of people in this room have experienced over the years. And so Databricks is a big part of that as well. Cool, and then a huge shout out and thank you to the newly formed data science team at GumGum. I think this group is like a month old at this time as it exists now. But Hannah Dow, senior data scientist, Colin Cyrilak, a principal engineer who built a majority of the viewability pipeline, and Marcin Kowalczyk, who developed the Instabill solution in 4 weeks.